This talk is going to cover kind of a broad range of themes. It's going to be a little circuitous. It's going to go through a couple of tunnels to get to a general overview of what we're trying to accomplish with the Observatorium here. Overall, I would say, there are going to be a lot of observability components, a lot of data components. There will be ML as well, but it all kind of fits together as a data product. All right. So, table of contents. A little bit of intro, some foundations and motivations for the product. Putting some pieces together, there'll be a little bit of tracing a single event through the entire pipeline. A little bit of conversation around the future, and then if you guys have any questions and answers, I'm happy to converse. All right. So DO is a global cloud hosting provider. We've been around since, well, I don't have the date on here, 2012. We have 12 data centers worldwide, and we build products that help engineering teams build, deploy, and scale cloud applications. You may be familiar with Droplet. That's our compute, our VM solution. We have block storage, object storage, and myriad other products. Cool, so I'm not going to talk so much about myself. The only thing I'll throw out is if anyone can figure out my past recorded music output, you get bonus points. And you can use my Twitter handle for that, which I'm not publicizing here. Observability applications and infra analytics, those are my teams. We are kind of like a hybrid of software engineers, data analysts, and we sit atop analytics infrastructure, basically. That includes things like Mesos, Kafka, Hive, Hadoop, Presto, and Looker, among other applications. All right, so what's the OA mission? To simplify and optimize internal consumption of data from distributed systems, to reduce incident MTTD and MTTR, that's mean time to detection and resolution through custom applications, to help define, maintain, and broadcast source of truth, performance, and reliability data to the rest of the org. All right, what's the IA mission? Oh, look, there's some similar stuff, right? So to generate insights through data for the infrastructure and wider organizations, to build and oversee a centralized data platform, and also to help define, maintain, and broadcast source of truth data to the rest of the org. So a little bit more general around the data. And those are the previous bullet points. So how can we actually achieve these things? Let's build the Observatorium. All right. So some foundations and motivations. All right, the what? So it's in sort of an oversimplified perspective, it's a centralized application to help reduce MTTD and MTTR, and in this case, it's the cost and impact of incidents. So improving the reliability of our overall cloud through curated data. Here are some of the motivating questions. I want to know the current health of the cloud. I want to see the live health and historical performance of all services that relate to Droplet creation. So this is just an example, right? Someone comes in, wants to understand how Droplet creation is performing, if it's reliable, how customers are seeing things. So you want to see the live version and the historical view there. All right, so there's currently an outage. I wonder if any outages like this one have occurred before, and if so, how they were fixed. So using past data to inform how to triage things and solve current issues in the cloud. I want to understand the reliability of any and all customer-facing products over time. So not necessarily as narrow towards Droplet creates, towards that function, but really the breadth of our product suite. Anything that can impact a customer and thus, our revenue. All right, and more internal facing. So how much of our team's weekly, monthly, annual error budget have we depleted as of today? Finally, a little bit more sort of towards the future. Literally, I want to know if there are any warning signs around the current performance that will lead to degradation of my services in the near future. So being able to predict service failures is pretty critical as we're building out our reliability suite. Okay, back to what? So how can we start building to answer these questions? So we'll talk a little bit about some foundations here. SLM, service catalog, and observability platforms. We'll dive right in. All right, service level management. So this is basically an umbrella that covers SLAs, SLOs, and SLIs. Some of you may be familiar with those. I don't know if you're familiar with all three, but SLAs is your traditional agreement with consequences. So typically what your customers will see as your public-facing expected contract of reliability, whether that's an external or internal customer. It applies to both. An objective or goal is the SLO, so what each team who owns a service expects or hopes for that service to perform at in terms of a level. And then your SLI is the actual indicator or metric that reveals whether or not you're actually meeting that SLO. Cool, so this slide is really to show you kind of the overall perspective, right? So SLAs are consumed by your stakeholders. They're the ones who see what you're promising. Your SLOs and your SLIs, you define those internally. And in terms of temporal prioritization, right, you want to do your SLOs and SLIs first and then do your SLAs. You don't want to publicize anything that you haven't validated. Right, so who owns those SLOs and SLIs? The service owner teams. So one key point here, as the observability group, we try to abstain from any type of ownership conversations with teams. We are really just the vessel, the conduit, the objective method by which we can surface the information. And where are these SLOs and SLIs defined? So that's kind of a hint at a catalog of services, right? So a service catalog is a pretty generic term. Some of you may have those in your organizations. It's a great way to basically centralize and standardize information. It's a central authority for distributed microservices in our case. So one of the main requirements here is that a service must have a complete service catalog entry to be allowed to deploy to production. This is something we're testing out right now. It's a little bumpy because cultural paradigm shifts here in terms of accountability towards restrictions and constraints. That's never fun for anyone. Let's define what that complete entry is before we say, oh, that's too much to ask of someone. All right, so here's just an example. Some of the details have been obfuscated for safety reasons, but you want to have your contact information, your severity level. You can read through the slide, but basically, a couple things I want to identify here with my pointer. Let's see, there we go. Cool. So you have your SLI defined here. It's an explicit query in this case in Prometheus, and your SLO is that nice float right there. There's links to like the GitHub repo and your Jira ticket project and all that kind of fun stuff. The other thing here, dependencies, it's an array of IDs. These are fabricated IDs, but the notion is that you are identifying the dependencies that your service has on other services. So things that your service depends on, which is pretty important down the line. All right. And then lastly, in terms of the foundations, I want to cover organizationally, in observability, we have a platforms group and an applications group. I'm the latter. In the former, we have a bunch of folks who support centralized systems, such as our centralized metrics, which are through Prometheus. Pandora is our internal interpretation / administrative portal for handling all the Prometheuses. And if you're not familiar with it, just a quick slide. It has a lot. It's very easy to implement and deploy at scale. It's very flexible in terms of how you generate these time series metrics. You can have counters, gauges, and what's great is you can fabricate recording rules, which from the previous slide in the service catalog, it's basically a recording rule SLI. So you're creating a query, it generates the data, it exports that as time series. Right, so this is just a configuration file. Pandora is the centralized authority here. It's the amalgamation of all these different Prometheus servers that are distributed globally. And it's simple YAML to configure it. The MVP from a couple years ago that we were doing in terms of centralizing data in Pandora and pulling it into our processing was leveraging a lot of Python and Spark and using a pull mechanism. And ultimately, this really didn't scale very well. So we generated a new remote write, or we injected the Pandora repo with some remote write capabilities, which allow us to earmark, whitelist certain metrics that then are pushed into our systems, which is a lot better. So that's the configuration there. Right, one little addendum. Polyjuice is something that another member of the observability team wrote to effectively coerce centralized logs in syslog format into Prometheus metrics, which is great because that allows everyone who's basically predicating their data, their telemetry on logging to also participate with our systems in metric format like this. So here, this example is a nice latency histogram, which is great for what we want to do. Right, so back to those, you've seen all these bullet points before. My point here is that it is a data product. We want to answer all of these stakeholder questions, and there are multiple customer personas, and thus we kind of have to start designing this as a product from a product manager perspective, which is a really interesting problem statement for us as engineers too. All right, so here's some diagrams coming up. Yeah, so this is currently, I'll go through some of the parts that matter that are pertinent to this conversation, but right here, you can think of this as the service catalog going into Pandora, remote writing into our system. Starting in the ingester, this is basically, the entirety of this lovely Observatorium system. We are leveraging a centralized Kafka bus and using it kind of creatively, by necessity to start processing, doing a lot of sort of streaming ETL. But I don't want to stay on this slide, right? Okay, that was supposed to come in earlier, but I started talking too much. But right, so here I'm highlighting a couple things with the gray and with the red. The red side here is primarily going to be like that's what the customer is going to experience. These are components that I want to highlight later on, and the gray is going to be a data flow that we're going to follow right now. Right, so back to the beginning of the flow. So we start in Pandora, we remote write in. It leverages all the SLOs and SLIs that are already codified within the service catalog. It comes into the ingester. Here's how we're defining those recording rules in Pandora. This is the structure of the data as it comes in. And you can see at the very bottom, this is what it looks like on the Prometheus API or on the UI. And above it is how it looks in the ingester. So this is relatively straightforward data. It's coming through in time series format. And now we're into Kafka, and we are digesting this. So we're effectively normalizing the data a little bit more. We are injecting it with a couple bits of metadata and processing it in a way that allows us downstream. This will make sense subsequently. Right here. So this allows us right now to basically process that data and write it with timestamp information and the payload down into Hadoop, our EDW, which then allows us to store things historically, which is critical for when we're moving forward into the sort of product features that I'll talk about. Okay, and the other side of this, so real quick, going back here. It's in Hadoop. This is just a raw row from Spark. It's in a Parquet file. The key point here is you have a lot of stakeholders who are curious about this data but aren't necessarily equipped with the skills to parse raw Parquet files. So we're coming in and trying to accommodate, Presto SQL is what we've deployed across the organization overall. So we want to make sure that it's reachable thusly. So we wrote something we called the trim reaper, which basically is an auto partitioner in Hive and exposes the data nicely for everyone. And there you go. So basically this is exposed to anyone with the proper Presto connection at the org. So backtracking a little bit, in fact I'm going to backtrack a lot real quick just to give, right. So I was just talking about this up here. This is where we're going into Hadoop with the trim reaper, and now you have this nice historical warehouse that's happening and being populated. And then we'll talk about how to extract it later. But I also want to say that in parallel, we're writing into a real-time front-end API and then the front end itself. So let's look at those real quick. Right, back here. Oop. Sorry. Yeah, so this is the front-end API. What we're doing here, which is really interesting, is we're taking multiple events and we're windowing them, and we're providing basically a normalization, a time normalization around the data. And so you can see that the start and end timestamps here are 10-minute boxes, and we have 20 of the observations. These are coming from multiple Pandora servers, and we're effectively normalizing them. We're averaging them out. It is definitely sort of, it's not as absolutely granular, but ultimately what it's going to be used for is it's totally sufficient, which is surfacing information here in real time on the UI that basically surfaces data that if you have anything that's not meeting its SLO, it comes out as an event, an unhealthy event. So categorically, all events on this live pane of glass across the entire cloud are going to be unhealthy things that anyone at the organization can come to and see, okay, this is blowing up, or we're having some problems across services A through F or whatever. So the great thing here is that you're able to see not only what the SLO is, but how far below you are with the SLI itself. Here, this is a latency, so the SLI is measuring much higher than the 200 millisecond SLO. All right. Cool. So going back, these are all the questions. We already talked about them, umpteen times. But it's all about how we're designing this complex data product from that architectural diagram to meet the needs of the stakeholders in the organization. Right, so a little different view into the structure. We have what we just saw in that little UI snapshot was the live pane of glass, the ability to have SLO and SLI historical data and aggregated reporting. There's the error budget API, an incident API, and a degradation prognostication API, which we might change the name of. But all right, so I just want to associate those thought bubbles, those requests with these components, right? So the current health of the cloud is likely in the live pane of glass. The reliability of any and all customer-facing products over time, you'll see that in our SLM historical and aggregated reporting. SLM, again, I'm just using as that proxy for really anything that comes under that umbrella. Our droplet creates working. Great, yes, back to the live pane of glass. Have they been working? Well, now I need to look historically, and I should probably look at error budget API to get a different perspective on how everything is performing. All right, and then the outage and the incidents. This is going to be, we'll talk a little bit more in depth about this one, but that's its own sort of standalone mechanism. And then forecasting whether there will be degradation in the future, right? So again, a little bit different on the architecture, a little bit more simplified, cleaner. You have your SLOs, your SLIs, that array of service dependencies. There will be service functions and tags. So you can say, okay, service X actually belongs to this set of product functions. So like a droplet create, for example. All that metadata will be part of the cataloged annotations. That flows into Pandora. It's tightly coupled, as we saw with Hadoop, in this case, RDW, and that flows up. Red is real time, blue is batch, purple is a mix. That's the code. All right. Right, so here are some of the end results of those components. Again, we've seen this before in the live pane of glass. So the kind of historical and aggregated reporting, it can be, it can run the gamut from, say, like, here's a searchable table of all these data points. You can search for your product name. It'll be indexed with Elasticsearch or whatever you need to do to run your free text analysis on your searching. And it allows you to see month over month, year over year, ultimately. This is just an arbitrary snapshot here. But error budget API, this is the algorithm. If you're familiar with error budgets, it's pretty straightforward. You have this many errors based on your SLO. And it's relative to how you codify your SLOs. Right. Right, so I squeezed this all on one page. So this is the incident API. This is a little bit more interesting. This involves clustering. The mechanism here, again, is to answer, has an incident like this or similar to this happened before? So naturally, that feeds the idea of like a clustering algorithm or a similarity matching algo. And so the notion is that in order, there's an incident. It happens. It's triggered. That could be, someone on our operational side says, all right, we've started this incident, it's at this severity level, and we are now, triaging it officially in this Slack channel, what have you. So we'll have a webhook, it triggers, annotation begins against all services. So what that means is there's a payload in the metadata around the data flowing into Hadoop, and that allows us to inject, say, like the incident ticket or basically some kind of annotation that allows us to say, like, at this point moving forward, all of these events, all of these services, all of these data points on our system are potentially related to this incident that's occurring. And it can allow for, simultaneous incidents if needed. Right. And so what we're also able to do is we do have historically that buildup of all the data sets over time that also may have been part of previous incidents. So we have, nice old time series to run as training data, as modeling. And so we end up building out the matrices and comparing these different sets of time series against each other. And you get the best matches. Whether or not it's an appropriate match will depend on how much there is overlap. Clearly, we don't want to surface red herrings all the time. But if there's an appropriate thing, then we will surface that information up to the operational agents. And we'll suggest, say, okay, this incident happened previously, and here's how it was solved, and perhaps use that to reduce your time to resolution. Right. So ultimately, what's going to happen and what's going to help us is there's sort of a manual feedback loop as well that comes into play. The incident's over. We lock the annotation so it stops writing the incident ID to these things. We then push into an incident metadata DB some of the interesting information that comes with it. So the time range of triaging, the teams that were involved, the potential services that were identified as pertinent to the incident. And so that is then used ultimately in the next incident. Right. And the ultimate goal here is to reduce MTTR. Okay. Sorry, one sec. Right, so forecasting failures, it's not dissimilar to the sort of data modeling that we just talked about. Ultimately, we have time series of every single service that's in our system. We have that historical data. We build those time series out. We are able to, with dependencies and other perhaps functional tags, things that are allowing us to group intelligently, we can then see, okay, if service A has had a problem historically, then it has an impact directly on service A and B, on B and C, sorry. And that, oh, in real time, we're seeing A has a problem, so we should start alerting on B and C as well. And so it's basically VAR in the context of stats, not soccer. But in this context, it's a relatively straightforward time series forecasting mechanism. Right, so stepping through again, historical performance and reliability metrics already exist, right? We've already warehoused all of this stuff historically. And we have dependencies identified explicitly between services, which helps. So we create vector autoregressive models, and we batch them and refresh them, so they're always being updated, so they're ready to forecast as needed. And then we enter what we call the alerting protocol. So currently this is configured within Pandora, within Prometheus for Alert Manager, but there's a potential next step here to build out a very explicit alerting mechanism for this type of alerting, so it's not confused with some of the others that are more generic, that are built in by other teams. So this is more like the Observatorium specific alerting. Right, so ultimately the goal is to provide warnings and messaging before the service drops too low, before there's degradation. Cool, so again, the goal here is to reduce the number of incidents overall, because ultimately we want to make sure that teams are aware, by being proactive on our side, we can make them aware of potential signals, which is great. All right, so real quick, 2020 vision, adoption, expansion, and impact. Okay, so just retracing steps a little bit. Service catalog is gatekeeper. One of the main goals here is to standardize how the entire organization defines their services, whether that's their SLOs, their SLIs, the names of their Jira projects, all that stuff. If you don't comply, you can't deploy. I thought that was an interesting use of the English language, so I trademarked it unofficially, but all right. Bringing ML into the broader data product toolkit and lexicon across the organization. So, traditionally ML at an operational, like DO is an infrastructure as a service place. We provide cloud infrastructure for users. ML isn't necessarily the motivation for building the Observatorium, but we're leveraging it because it's the right tool for the job, depending on what API we're building out and what the end goal is and what we're trying to address for customers. So leveraging that as, okay, here's the POC, we're using ML, this is how we're using it. We're not necessarily saying like you need to be a data scientist or a machine learning engineer or anything of that nature to participate in this. It's broadening the appeal of the efficacy. Right, and so as we're building out new product SLAs across the board, so droplet, block, object, et cetera, we want to have that obviously predicated on real data. We don't just want to fabricate it out of thin air. So the Observatorium becomes the source of truth for those SLAs. Ultimately, we also want to build out telemetry to understand who's using the Observatorium, how they're using it, basically understanding what could be more efficient, how we can iterate on our product design as well. And demarcating between staging and pre-prod environments and ensuring that folks understand the reliability of their associated services before they deploy to production and potentially cause a mess. Expansion, right. Our goal, all services have SLOs and SLIs defined no matter their proximity to customers. So you're gonna have, dependencies, the underbelly is significant, right? So you're gonna have so many things in the microservice cloud that a customer will never see. Nevertheless, it needs to be instrumented properly. So we're getting there. We're 90-something% right now, which is great. Error budgets are available ad hoc, so anyone can come in and look at the error budget API. They can search for a service, a product, any sort of level tiering, and they'll be able to understand sort of how much of an objective error budget has been depleted at a given time, which is great for managers and leadership to come in. All right, and then this is a key too. We've only really talked about Prometheus as the source data, but we do have a lot of other data points, data formats throughout the org, right? We have Kafka streams, we have a bunch of relational databases and NoSQL and all that. So we need to be able to build out plugins to the Observatorium, to the ingester point, so that we can leverage and standardize the data flowing through. And again, the production staging dichotomy, right? We want to make sure that things are properly measured and staging before deployed to production. We also want to integrate directly with our deployment tracker, which will allow us to overlay deployments as potential intervention analysis or what have you in terms of the impact that an explicit timestamp deploy will have on the reliability of the cloud. Right, impacts. These are all kind of overlapping, just arbitrary terms, right? Fewer customer tickets and complaints about reliability. That's pretty standard. We want to reduce that. Teams will iterate on their SLOs and work to reduce outage counts and overall time running degraded services. Again, this is pretty common sense. Teams don't want to have crappy services, but this is a way for them to take ownership over that and define their SLOs and say, look, we are the ones who are holding our own feet to the fire on this. Right? More mature pattern recognition among microservices leads to better cross-team developmental collaboration. So you have folks who are overseeing and privy to how different parts of their own pillar, say the compute pillar, for example, all those parts are performing, and starting to recognize, again, when one service goes down, it has an impact on another service. Ultimately, that can only lead to better conversations between teams and more cohesive architecture. And ultimately, right, we want to reduce MTTR. So incidents are going to happen. What can we do to actually help people fight those incidents and solve the problems? All right, that was under 30. Any questions?
Hey, can you talk about if you guys do any automation on like the service YAML file? There's a lot of stuff like PagerDuty things, dependencies. Is that just all done by hand, or like, do you have any ideas of how you could automate that?
Yep. So we're currently migrating everything out of YAML into a backend. We have tracing deployed. We haven't necessarily tested it all the way through to believe in it fully, but ostensibly all services have tracing just as they have logging and metrics. It's part of the OAR, the operational acceptance readiness process. And so by leveraging the data flowing through the tracing, we can basically infer all the dependencies and generate those.
Yeah, one more question. Thank you, Alex, for your talk. That was great. Maybe two questions. So the first one is, because you mentioned that, for example, you observe and monitor how droplet is being created, and the question is, do you monitor your own observatorium? I mean, how do you do that? And the second question is about data retention. I mean, all your work is, I guess, about real-time processing the data and monitoring the incidents. And the question is, how do you storage all this data, and what's the retention?
Yeah, totally. So the first question, I would say, we would be complete hypocrites if we didn't instrument our own service. And the SLOs we're defining, they're multifaceted. So we're looking at things like attempts at hitting our historical API, UI, different pages on the UI, things of that nature. So that is all generated. We have an external Prometheus scraper, and that just exports into Pandora naturally. And so in terms of retention, we have the luxury of being an infrastructure organization is that we do have relatively solid headroom on our warehouse store, and so we basically are able to push data into Hadoop, and we do have archival mechanisms after a certain distance in the past, but we have the ability to aggregate those to the point where they're still useful. So we don't even really have cold storage yet.